Hello, I'm Amir Zaburakavan from Algoritmi Academy. I'm admin of this year Indian Prelims ICPC contest, and I'm going to solve problems for this contest as I should ensure problems are high quality, and together we are gonna solve these problems and I'll show you solutions for these problems. So let's start. Let's start with the problem named equations. So it's a real-time solving session. So I don't know the problem. I'm gonna read it right now and understand it and then solve it and we'll code it together and we'll get accepted at the end. So it says that there is a hidden array A with n non-negative integers. Your task is to process Q queries. So the first is you understand that AI plus AJ is K. So sum of two elements are given. And it asks to calculate and print value of AI plus AJ or minus 1. If it isn't possible to calculate it, uh, and all of the information are consistent. So that's it. It's the problem. So let me start thinking a bit, and I'll tell you if I found something worthy. I'm thinking of making a graph and putting it this weight curve between I and J. Maybe it works. Uh-huh. So I think I'm understanding what is happening here. So uh, consider a connected component in the graph that I described. So we put an edge between I and J with weight K. So what does it mean? It means that we know that AI plus AJ is K. So we can never find uh, There is another issue here. Okay, I think I have an idea. So we will. I'm not 100% sure, but we can try it. So okay, so uh, we if consider a connected component in the graph that we are making. So if this connected component forms a tree, we can find the values of each element. But if it's more than a tree, I mean it has at least one cycle, we can find all the values in the cycle, and for sure we can find the values for all the elements. So our task is to find a cycle, then find all values, and that's easy to continue. We can find everything uh, in that connected component. Finally, there is another case when it's a tree, so a connected component forms a tree, but the query of second type is exactly asking about an edge. So then we can find it and print it, and it can be solved. So let me select which language I'm going to code with. Uh, for this problem, I prefer to use C++. Uh, so let's start coding. But before that, I'm gonna uh, show you again what I'm exactly going to do. So before I start coding, we are going to fix our solution. By fix I mean we need to make sure every single part of our solution is working, and then we'll start coding. So we'll initialize a DSU disjoint onion set at the beginning, and we get and we process queries of type 1 like this. When we receive a new query of type 1, uh, we first add it to DSU to make sure if it's making a cycle or not. If it doesn't make cycle, that's it. No worries, we can just add it. That's very easy. Otherwise, we know that it's going to make cycle. If it's going to make cycle, note that for each connected component, only the first cycle is important. So if we already saw cycle in this component, that's not important. We just continue. Otherwise, uh, we found a new cycle. We go find values for all these elements in this connected component, and how. Uh, Let me see how we can find that. So let me show you x plus y is k1, y plus z is k2. What we can say about x and z? We can say that x plus z is k1 minus k2, right? And what if z plus t is equal to k3? In that case, if we can say that x plus t is k1 minus k2. Oh no, it's like this. K1 minus k2. Okay. And now with having all this, if we add the third equation, we can have x plus t is k1 minus k2 plus k3, which means that even when there is no cycle, we can calculate something. So the first thing I said was incorrect. So the thing is, consider this case. We have some queries like this. 1, 1, 2, 10, 1, 2, 3, 12, 1, 3, 4, like 20. Then we can, if it asks us 1 and 4, we can't say I don't know, because the answer is 10 minus 12 plus 20, which, yeah, we can find the answer. So so let me say, when we receive a query of second type, if I and j are in different components, the answer is -1. If I and j are in a component with at least one cycle, we know AI and AJ already, and we can find the answer. Oh, that is not totally correct. So if each of I and j are in components with at least, okay, so it's like this. If we already know the value of AI and AJ, that's it, we can easily find the answer. So AI plus AJ, we can calculate it. Otherwise, if I and j are in different components, we can't find the answer. Otherwise, now we know that they are in single component, and the component forms a tree. If the distance between I and j is even, answer is -1. Uh, otherwise, what does it mean? They are in single component. This component forms a tree, and also the distance between them is odd. Uh, otherwise, consider the path be like I W1 V1, then W2 V2, then W3, and so on, and finally J. The answer would be W1 minus W2 plus W3 minus W4 plus so on, right? So there is 4 cases, and we need to think very carefully to write code for this problem. So it's not that easy. We shouldn't. Uh, it's a common practice everywhere. You shouldn't jump into coding before you 100% sure that you know what are you going to implement. So let me think and make sure I know what I'm going to implement. Okay, so at each moment, any vertex like I can have four different can be in four states, either in one of the four states that I will say. We know AI, different states of I. The first is we already know AI, which is easy. Otherwise, I is root of a DSU component. Otherwise, AI is the k minus a root, or AI is k plus a of root. So always it's going to be one of these cases. Is that clear? So we sure, for sure we can find that at each moment one of these cases are going to be the state of AI. So so uh, let me make these states easier to understand. So uh, first is I if the root, and we know the AI, or we don't know AI. Otherwise, one of these cases apply. So we actually don't need to know the value of AI if it's not root. So either we know the root or we don't know, and that's it. So we have two kind of components, DSU components. The components that we know the root, and for sure we know all the elements in it, and the components that we don't know AI, and we don't know the elements themselves, but we know the relation between the nodes inside the component and I at the root. So okay, I'm going to start coding. Uh, so let me remove these things. I copied someone's code before I start this, so it's not my template. And then let me change it to something bigger. Okay. I define array pair. Also, I define array A. Also, I defined a boolean reverse. That means that if reverse of I is true, then we know that this is the case. AI is it has reverse somehow reverse relation with the AI of root, and then gonna be easy. So let me think about when we merge what happens. Okay, I understood. So it's like this. So actually it's a bit uh, complicated DSU thing. I may solve So the DS you think is a bit hard, not the whole problem. So the problem as a whole is just this DS2 thing. So I think I solved maybe 5 to 10 problems that had harder DSU than this. But yeah, we can try. That's not that hard. So uh, first of all, we need to implement function root. If parent, if there is no parent for v, that's easy. We just proceed with returning v. That's it. Otherwise, we need to find the parent, the root of so let me write like this, and now we want to change this thing. So if r is already part of this, return r, and that's it. Otherwise, I need to do something with AI and rev and all of that. So what I know, so let me turn it into int. And do like this. So okay, so I know two things. AV is equal to so I'm trying to understand how I'm gonna explain it to you. Okay, let me change it to K. And now I can better explain it. If I is root, AI is KI. Otherwise, AI is like this. Okay. So I know that A of V is K of V plus rev V times APV. And also, I know that A of parent of V is going to be like this, right? And you know that as I'm doing past comparison, this is A of R. So what I'm going to calculate should be K prime of V and rev prime of V that satisfies this condition. So first two are given, and I want to find the value for K prime and rev prime. Okay. So first of all, uh, uh, so these two are things that I want to find, okay? And these two is the equations that I already have. So that's gonna be simple. So I'm going to replace this in the first equation to see, okay? So AV is equal to this and like this. So I will do like this. And okay, based on this, so finally I'm going to change it to this and returning this. So here I need to, so first let's find the rev prime, okay? So rev prime is this. So rev of v is going to be this. So actually it's going to be multiplied by this. And the only thing that remains is this. So we can say that kv plus equals rev v times k of this thing. And then we change rev, and that's it. Yeah. We implemented the hardest thing here, that was the root function, and okay, that's it. We found that the remaining part is much easier. So let me start with reading N and Q, and then feeling like this, and then filling all rev values to 1, and then to read queries like this, and then in T-I-J-K, oh, this K, okay. I-J, if T is 1, and else, okay. So, and also, set all k to -1, because if for a root k is -1, I assume that we don't know that. So let's start from here. uh, if roots are equal, okay, if roots are equal, if k of the root is not -1, we simply continue. Otherwise, here we have some chance to find the root itself. When we can find the root, so we can find the root if the distance between I and j is even. Otherwise, I think we can't find it. So let me write the, so if their distance is yeah, so okay, and there is a corner case where, so I'm thinking of somehow, okay, so if the distance is odd, we are gonna skip that. So how we are going to do this is, yeah, by simply calculating the rev things, or rev of I equals rev of j. So if that's the case, we are going to continue, just continue, that's it. Otherwise, what we know is uh, this. Okay, so these are the three equations that we have, which result in simply this plus this is equal to this one. They are integers, okay? So and we know that rivs are equal, so we can write like this. this. Yeah. So this is like this. And finally, that's easy to find the ARI, which is this divided by what? This, right? So, uh, that is true. That is completely true. But first, you need to let me. So in the case that so let me add another variable here. I'm not confused. So we first make vowels are all -1 and k. Okay, that's it. And then we know the value of this is going to be exactly this. Divided by 2 times revision of I. That's it. It seems good. Looks good to me. Else. Else. Else we know that we want to make Ri parent of Rj. Okay. And that's a bit tricky here. It's a bit tricky here because yeah, because we have, so it's like this. So they were two separate trees, and we have an equation that shows relation between two different vertices inside these things, these components. And now we want to find the relation between these two to make Rj, Ri parent of Rj. So that's not going to be an easy task. So let me start like this. So we know that okay, and also there is a case that we already know the value of Rj, and we need to set this value for Ri2 to make sure that everything is working. Here we can, in this case, we can easily skip the edge and just put the value and that's it. Am I right? Okay, if we know the value of Rj, that it's not. So if we know the value of Rj, we need to find the value of Ri2. How? Let me move this one here to avoid duplicates. Okay, so we know that ki plus rev I times ari plus this is equal to qk, and we know all the values except this, and we can find this, right? So value of Ri is going to be qk minus all this and then divided by rev I. Actually, as they are always 1 or -1, we can use multiply instead of divide, and that's it. So we continue here too. So it's the last case in which we want to find a of Rj based on Ri. So a of Rj is k of Rj plus rev of Rj times a of Ri. And we want to find these two values. To do that, we start with, again, we use this equation in line 60, and what we want to do is find a of Rj, right? So I'm gonna move everything to the other side. So a of Rj is equal to all these values. So qk minus all these values. And finally, times rev of j, and then I need to make it clean. So to make it clean, it's gonna be a of rj equals some constant. There is rev of j times qk minus rev of j okay, I can simply multiply to everything here minus ki minus kj and plus and minus rev I times rev j times a of ri. So rev of rj is going to be this. Oh, it was a lot of math and equation solving and all. And k of rj is gonna be this. And parent of rj for sure is going to be ri, and that's it. Oh guys, it was a super math problem. I didn't expect this. Okay. For answering queries, we find the root. If value of ri is not -1 and value of second root is not -1, return. Let me implement the function named find val, which works like return val of I. Otherwise, okay, root of I, and then return ki plus rev I times value of root. That works, right? Interesting fact here is in this case it's also this. So for these roots, k is always 0 and rev is always 1. So okay, that's it. So don't hit this function. Or we can simply write like this. Okay. Okay, we don't need this. see out ki plus ri plus kj plus size thing, and that's it. Else if ri is equal to rj, and also their revs should be equal. So rev I is equal to rev j. If that's the case, we can find. Otherwise, the answer is -1. And that's it. We are finishing that. I hope so. So it's like this case. Okay. And we want to print the answer. Okay. We want to what? They need to be different, sorry. Oh, if that's the case, ki plus kj is the answer. So yeah, that works. So this is reverse of that thing. We sum up these things together, and that's it. So yeah, I hope that this works. Okay, I'm done with it. Let's start with some. Hope it works. Debugging this code is not going to be an easy task. People, pray. Oh, it's printing all negative things. I expected that. So don't worry, we will fix it. Not even a single correct answer. So okay, I'm gonna start with something very easy. Even easier. So what is the sum of 1 and 2? So that is correct. So I tell you that is 17, and then tell me, okay. So it's not that hard, people. So it's printing 17, but with a negative sign. That what is the cause? So somewhere here it's the cause. So we need to find it. That's it. So we need to put a breakpoint here, run the program. It comes here, and now that's going to be easy. Let's find parent of 1, which is 0, and parent of 0, which is -1. That they are correct. So the root is 0. That is correct. So k of 0 should be 0, and k of 1, it's -17. So it's saying that okay, and what is rev of? It's -1. So it's saying that a of 1 is -17 minus a0. Is that correct? No, it's not. It's not, because if you move this to the other side, it should be, so it's not correct. So the rev is actually correct. So the issue is here. the ref is correct. It should be -1. But the k, it's incorrect. So let me see. Oh, I think we should swap these two lines. So let me check this will work. Okay, this is working for this test case, but let's see. So it's sometimes working, but sometimes no. So when it's working, it's working. So for 5 and 7, they are correct. So there are some extra negative ones. Let's see. So the first one is here. Is this? No, it's this one. Okay. Let me remove these 3 and change it to this one. Okay, and then we can remove these 2. And okay, now I have just a single -1. So let's see why it's saying like that. So 1, 2, 3, 2, 3, 4, 4, 5, 1, 5. Okay, so all of the values in this should be already known. So it shouldn't say I don't know the value. So let's see what is happening here. Okay, so let me put a breakpoint here to see if it's reaching this. Oh, it's not reaching this. Why it's not reaching this? Strange. So let's see. 1, 2, 3, 2, 3, 4, 4, 5, 1, 5. Here it makes a cycle. Okay. Let me come here and print Ri and Rj to see what is happening here. Oh, sorry. They are equal. Maybe the issue is with refs. They become equal. And when they become equal, they make some problem. Okay. Yes. Okay, let me make some easier query. Just like 3, 1, 1, 2, 10, exactly something like this. Yeah, let me copy paste it here. 3 and 4, 2, 1. Not this. 2, 1, 2. It's not delicious because it's also the answer. But no problem. Let's see if it's going to do that or not. So no, it's not doing its job. So let's just take a look to logs, okay? So it means that it didn't work, but it should. So when revs are equal when revs are equal, we go escape. But why? But why? Let me put something here to make sure. Actually, so when revs are not equal, it should escape. Oh, I think I fixed it. I think I fixed it. Okay. 5, 4, 6, 7, and 8. Oh, people. Oh, folks. I think it's now correct. Pray that it gets accepted. Okay. Let me make sure everything is correct here. Yeah, everything is correct here. That's a very big code full of full of equations. Also, I hope that it gets accepted. No, it failed on the second test case. Okay, it seems that as far as I know, the judge for first problem is needs some updates. So we'll continue with the second problem, and we'll come back soon when the judge for first problem is fixed, and we'll resubmit to see what happens. Okay, now the second problem. What does it say? It says that Chef was trying to solve famous problem counting coprime pairs for his friend. The problem is straightforward. Given an array A, find the total number of pairs of indices that AI and AJ are coprime. Being too busy with his delicious recipes, Chef didn't have enough time to solve the problem, so instead of actually solving it, he guessed the answer and gave it to his friend. And yeah, it gives us integer k and asks us to construct an array, and also it gives us n. So it wants an array that of length n, that the number of coprime pairs is k. Okay, and k is very big, n is very big, and we can set the AI, and that's it. Okay, so Okay. So my idea is like this. We go find the biggest uh, integer, let's say a. Okay, so the first idea is like this. I will fix it. So uh, we go find the the largest s that s squared is less than or equal to k. We go make s numbers which are pairwise coprime, and then we go to next group, but it doesn't work because what we can do with the next group. Okay. So we go, yeah, that's easy. So we go fill all A's with 1. Okay. And then we get very big answer. Is that true? And then we start by some prime number, let's say 2, and then we put 2 in some indices. When we put, for example, so consider we put 4 2's right now, and we add the 5th one. So adding this decreases the number of pairs of coprime numbers by 4. Is that true? So it's like uh, yeah. So to make you understand it better, let the total number of pairs of indices such that AI and AJ are coprime be the score of array. So first I fill the array with 1, and score is equal to n times n minus 1 divided by 2, which is the maximum. Then I start to decrease it. How I decrease it? I add 2 and then 3 and then yeah, I go for it, and when adding a new, I select so I select primes one by one, like 2, 3, 5, 7, so on. When I select a prime, I start adding it until if I add this prime once again, this score of array falls below k. I skip that and I go to the next. And that's it. So that's the answer. Let me think about a special corner case. So the corner case is, what if n is large and k is 1? Is that, does it work? I mean, can we have only one pair? Yeah, it works too. No, it doesn't work. So, can we have two elements that are coprime with each other, but they are okay with other numbers? No, it can't be possible. So it can't be possible, right? Because, yeah, so it can be possible. So let's do it with Python, or yeah, we can do it with Python. It doesn't need to be done by C++. That's going to be easy. Okay. Let's start with reading number of test cases. Input while, then I read n k and like this, and then I fill all the arrays using uh, 1 and the car is n times n minus 1, and then while car is more than k, is prime for I wow, that complete is super. There is a single case when n is 1. Okay, we can leave that, and current prime is 2, while current prime the array, and while okay. Current prime plus while not is prime, current plus equals 1. Finally, a plus minus 1 times n minus len of current a, and finally print array. Yeah, it works. And here and here. So we are gonna add some primes of current prime. So how we are gonna do that? We are gonna do that in this way that I will tell you. Okay. Number of primes, let be 0. Okay, let be 1. While number of primes. Okay, while current is still more than k, even if we decrease it by this number, add 1 to it. So when we are adding a new prime of this prime, the current score will be decreased by the number of elements, right? So let them be at the beginning 0 and go add them one by one, and finally you need to add like this. Current prime times number of primes plus 1, and that's it. Here if n is if car is not k, or length of a in exceeded n, print -1, else this. Okay, let's see. What? There is an issue here. There is an issue here. Okay. Oh. really don't understand this. Okay, let's do it one by one. It says all one, but it's incorrect, right? No, it's correct. No, it's correct. Okay. That works. Let's do it. Okay, it's -1. That's correct too. That's correct too. For this, it's not gonna reply. Why? So 6, right? 6 times 5, then it's 50. Let me ask it to print its current prime and current. Oh, it's going very high. So it's 8 and it's 1 7, so it can add 2, and that's it. I don't understand. So that would fix. 1, 6, 7. And it says -1. Oh. Oh, okay. Why? Because it tries to fill it with some 2, 3, and 5. Let me ask it to print A instead of this. 1, 6, 7. Oh, that is super long. Okay, at the beginning we want to decrease it by 8. So here we decrease it by 1, then 2, then 3, and then 4. What the hell? So 1, 2, 3, 4. It's 10. So that's it. Why you are doing like this? So let me check. Copy and okay. 1, 6, 7. Oh. So first of all, it decreases it by 6, which is incorrect. Maybe this. Yes, that is true. Now look, decreases by 1, by 2, by 3, and then by 1, and then by 1. So 1, 2, 3, 6. It becomes 9, and 1 again, and again. That's it. Okay. So the array becomes so long. So here it seems like a corner case, and there exists an answer like this. That is a bit complicated to understand, but it works. Okay. Uh, I need to leave because I have a class in a few minutes, but I will be back with solving this problem. Okay, folks, so I'm back, and what we have here is some time passed and we had a rejudge, and yeah, our first solution was correct. So you can see the first solution here. Also, you can find the link to this solution. So that's it. We solved the first problem and everything was correct in the first try. So we are going to solve, yeah, we were solving this, if you remember correctly. And here what we see is yeah, I was trying to solve it, and let me open it up again. I had some lunch and now I'm back. So try to solve this, and we were unable to handle this specific test case. And yeah, I'm thinking on how we can do that. So let me go with some other examples maybe. Yeah, also this doesn't work for this. And what about but this works. Okay. Okay. So yeah. So all of these cases should they have answer, right? For example, for 161, it says no, -1, so there are just some log informations, but there is this answer, right? So the answer for this case is actually like 236666, so it works. So all the the only pair that are coprime are this one. So let me see how we can handle this. Just a note here that thinking when a record is in process, and also I need to explain, it makes people, and including me, much slower. But yeah, you should try to solve faster than me, so when I'm quiet, you can go ahead solving the problem and use this time. Don't wait for me that I solve problem. This is not a editorial video. This is a real-time solving video. So I'm really solving problems. I didn't think about these problems before I record, and I'm recording everything. During this time that I was absent, I was just having class, and then I had lunch, and I'm back. Even I cutted my hair, so you can see that my hairstyle is a bit different. Okay, let's continue to this and stop talking about meaningless things. Okay, now let's see what does it print for. Oh, again, -1, but it only uses very few number of primes. That's interesting, right? Okay. Maybe backtracking can work, but it is not that easy in this case. I'm still thinking. I'm thinking about consider the situation that we already add 4 2's. Then we either need to add like this that will exceed our 6 number of elements that we have. Yeah, it doesn't work. Or yeah, consider the case. Instead of adding all these, we go do something else that I'm thinking about. So I think we should remove these 2. So we need to remove, we need to decrease the score by 2. That's why we do like this. And if we add another 2, we decrease the score by 4, which is not acceptable. And also if we add something like 6 or anything like that, that's the case. We decrease it too much. It's not acceptable. So why not removing 2 and then adding a 3? So it's like 2 2 2 then 3. By adding 3 we don't decrease anything, but then add this 6 we decrease by 4, right? So we don't decrease using this, by this 1, by this 2, by this nothing, and by this 4. You understand what I'm talking about? So now, so our goal was to reach a score of 7 from a score of 15. So we need to decrease by 9. And now we decreased by 7. And then if I do another 6, it doesn't work because it will decrease a lot. So I need to decrease by 2, which is again not possible. If I add another 2, I decrease by 3. If I add another 3, yeah, that doesn't work. So what about this one?
and decrease by 0, then 1, then like this, and then 4, and now I already decreased by 6, and oh, again it doesn't work. So let's see how it did. So it's like 2 2. So let me try to translate it to what is really is 1 2 2 3, and then 6 6. I think it's like this: 0 0 1 0 4 4. Ah, that works very well. Oh no, it's like 3 3. So how it's working? At the beginning it's 15, and it needs to reach 7, and it's not working. I don't understand. So it should decrease by 9, but this is 4, but still 0. So it decreased by 8. Wait, maybe I made some mistake here. So let's have like this. So it decreases by 0, then by 0, then by 1, then by 0, then by 3, and then by 4, right? So sum of these things is 8. I think the sample test case is wrong. It's 8. Okay, let's calculate the vice versa. How many numbers are coprime with this before this? 0, 1, 1, 3, then 1, and 1. What is the sum of these numbers? It's the 1. Oh, okay. So it's some mistake here. Must be. I don't understand. So 15, and it was. Oh, my bad. We need to decrease by 8, 9, not 9. We are 15 and we want to reach 7, so it needs decrease by 8. Okay, so 1 2 2 3 6 6, it's the solution. So it decreases by 0, by 0, by 1, by 0, by 3, and by 3. By 3 and by 4. Okay. So that's the case. Okay. So what I understand is we should have some package for decreasing by some values. Maybe. Consider the case that we only use 1, 2, 3, and 6. Let's see what happens. Might have the answer. So the number of pairs, the score is gonna be 2 times. So let the numbers be O. So n1, n2, n3, and n6. We have these numbers. Okay, consider the case. The score is going to be n1 times n1 minus 1 divided by 2 plus n2 times n1 plus n3 times n2 n1 plus n2, and that's it. And and also plus n1 times n6. So basically it's n1 times okay. So I'm thinking if we can make everything using it. We can make. I'm thinking about if we can make all of the cases only using 1, 2, 3, and 6. So this should be equal to k. I think it's possible. So let's see. And another constraint is n1 plus n2 plus n3 plus n6 is equal to n. So let us make it a bit simpler. Okay, it's now much simpler. So basically it's so if we need big answers, we increase n1 to the half. So maybe we can pick the biggest n1 and then we put some 2 and 3 to that are equal to k, and then put some 6. Hmm? No. No, no, no. It's not gonna work. Oh, thinking about some different ideas. I'm thinking about if we put some 1 in the beginning of our array, the new problem would be the same problem with n minus 1 elements and k minus n, and that's it. So if k is at least n, we can do that. Otherwise, I have some gibberish idea. I say that if k is at least n, so let me implement the function. No, it shouldn't be correct. Let me think more. Okay, let me something like this. If k is at least n, print 1 else if. Now we know that k is less than n. Okay, I just want to try something. Okay. No. Okay. Printing 1 to the hell. What is this test case? This works for this one. That's because, okay. Okay. This easy idea is working actually. So, guys, that's the idea. I was so dumb not to understand this. Okay, this red. Just a easy print. Okay, let me run this code. 11623 seems correct. 23, and this is correct too. Okay, let me check it. Judge for this problem is working or not. Oh, I'm submitting this code as C++. Okay. No. It must be correct. This says trying answer for the first test case. Okay, I think same goes here. Judge for this problem is also problematic. I will ask them to maybe fix it, and I will come back again. Okay, it seems that I was doing incorrectly, and AI should be at least 2. So that's the note. So if we want to do that, that can be done easily, I think. So instead of 1, we print 2. Instead of 6, we print 15. And instead of 2 and 3, we print 3 and 5. And I think that can work perfectly. Like this. 2, 2, 15, 3, 5. this 10? Like 2 plus, no, for sure it's not. So it's 2 plus 2 plus, there is an issue. So okay, I can do that. Still I can do that. From 2 the next prime, and let's define this one here. Global and is 2. Okay, I know what to do. While not is prime, current prime, added, current prime plus return -1. If that's the case, I print next prime. If this is the case, I print -1, or maybe vice versa, because if I need to print so many of them, it's good to have small ones at the end. Okay, let's just start like this. So this is very big, right? And to like this. Okay. While it's not prime, -1 finally +1. So we know that every time we have new 1. It's a simple integer. Then we print next prime. Here we print 6, and here we print 2 and 3. Let's run it. Okay, this adds 4 to answer, then 3. This nothing. Okay. Nothing. 1, 2, now 3. This one adds another 2, 2 and 3, 5, and this one adds 3. Wait, what's happening here? So this is the case, right? This one adds nothing. This one adds 1. This one adds 2. This one adds 2. This one adds 3. What is the sum of these things? They are 8. I really don't understand this. So for this, it needs to be always. So why it prints 6 here? So this was incorrect. So still printing print and then k. Oh, okay. Okay, it's raining more and more. That's great. So let me see. Let me see. So by adding that, it decreases k by 5. And now k is 2. Okay, let me see. I think it's okay, it's good. These are all good. Yeah, they are all correct. The only thing that remains is next prime is so slow. So I need to find primes in a better way. And yeah, it's Radisson's algorithm for sure. So let's start implementing that. Is P is true for max n. Let me try this. Max n is equal to this one. This is like this. And then for this range starting from 2, if not is prime, continue. Otherwise, for j in range I times I max step I set is prime to false, and that's it. Okay, and let's reverse this function. Prime global current prime while not is prime current prime minus equal 1 current prime again minus equal and return current prime plus 1. And it should work. Okay. Let me try this. Looks good to you? Let's submit it. We have still wrong answer on the first test case. Let me try this some other. Says that. Okay. I think we should be good. This is correct. This is still correct. Like this. This is incorrect, right? This is incorrect. Yeah, this is incorrect. Why this happens? Am I right that this case doesn't happen ever? Because it's if n is 2 and k is 1, it goes to this condition. This is true. This is true. And so, yeah. I think this never happens. But let's try. Okay. Yeah, this is never happening. Okay. That's the case. We can change this and also change this. And the only thing that remains is this one. So instead of 6, we need to rate multiply of all primes that come next. Can they be very large or not? So if this case is failed, so k is less than n minus 1, and this goes and finally it stops somewhere. Okay, let's fill it with -1, then set it to, oh, it can't be done. Check. So after 6, we may encounter some so after 6 only 2 primes appear. So the 6 is false. So state -1, then switch state to 2 if the state is -1, do like this, else if the state is 2, print 2, and then and else state is 3, print 3, and don't change the state. Okay, now we run. What? This is true too, but this is not true. This should be 3. Okay, I think this works. Also, it's not that clean. I will explain. So let me first run, and if we get accepted, I will explain. No, still right answer. Let me oops. Why this is 2? But okay. This is okay. This is not okay. Absolutely no, because these answers are the same. So let's see what happens here. So it puts something, and we try to be multiply of everything that was like here, and that is true. I understand it. Okay. So let me explain my idea. So we come from left to right. There are 2 cases. This case or this case. I name this case as pick all and name this case as skip. So pick all means that I put some prime number here and I make sure that this is gonna be coprime with everything to the right. So clearly it will decrease k by n-1 and I pass on. Otherwise I skip this position and go calculate the answer for the rest. I mean, I decrease n by 1, but I don't touch k, and then I put LCM of these numbers here. I mean, actually, I put all the multiply of distinct primes of to the right here. So that's my idea. So at each position, either I skip or I pick all. So that's the idea. But here, as you can see, I made a mistake. So here I wanted to just skip, but suddenly this prime is also divisible by this, which doesn't work. So I need to first mark these indices as a skip or the multiply, and then start from that side and I can make it. So let me make array of primes. Array for okay, now I have list of primes. So it's pick all. This is skip. And now I want to go from the other side. First I put move and I use ptr. And then I start from n-1 if ai. So if I here I need the prime, I put here's ptr, then I go to the next, and also I do like this, otherwise I put this to mul, and finally I print a. Looks good to you? At least it looks good to me. So let's see. Oops, all one. Why this is like this? We need a prime here, but let me put a breakpoint here to see what is happening. Oops, it's gonna take so long. Let me stop it. Let me print pairs of 0 and pair. Okay, first 10 primes. 2, 3, 5. That's okay. It's working. Why? I can't understand. Oh. Okay, that works very well. That works, and also this works. Let me try with something bigger. It was let's try some big K. What should be correct? Okay, but if K is more than this, okay, that works. But okay, this is true too. Oh, looks good to me. Let me solve it. These kind of constructive problems are so hard for me. I always ruin them. Hope that this time this gets accepted. Yeah. Okay, fine. Okay. I'll do some rest and come back to you very soon, in just a few minutes later, to solve the remaining 4 problems. Okay, while I was away, I found some better way to do this, so I'm gonna show you before I move on to the next problem. So in this case we print PRs, PTR, and then PTR is equal 1. Otherwise, in this case, if PTR is more than 1, we change it to 1, and we print 6 and end it with a space, and end it with a space. Else we print 2. I believe that will work. Six, 2. What does this 2 means here? First print some prime, then this one. Again, this wants to print this. Let me try this. Okay, this is working, I think. Okay, this works. So as you can see, it's much
easier, and time complexity for last code, it was big because we were multiplying a number with a very big number mole, and that's also, this one is much better. Let's do another problem. I think that I already solved the two hardest problems. I don't know, but I hope that this one becomes a piece super easy because I need some rest. So you are given integers n, k, and k triplets. It says that find an array A of length n that satisfies the following conditions. All elements are in range n, and the minimum of each triplet is not mj. Okay. If there are multiple valid arrays, okay, and print no. Okay. Understood. So n is not that much, k is not that much, and okay. So let's see some examples. 1 and 2 minimum is not 2, that's correct. 2 and 3, between 2 and 3, in the range of 2 and 3, minimum is not 1, that is correct. 2, minimum is 2. And another query, it's not working, it's correct. Okay. So okay, so we have something like a board n times n board, n rows, n columns. In each column there is a token, and when it says minimum of this range is not this, it's either there is at least something below this, or there is nothing in this row. So there is something below it, or everything is above it. Oh, I hope that it's not too sad. Because if it's too sad, I don't remember the code for that. Yeah, I can for sure copy paste the code from my template, but yeah, just a comment. Okay, it seems to me like fill the array with the fill the whole array by 1. Then start reading triplets that they say minimum should not be 1. So when minimum should not be 1, they are all elements in this range should be more than 1. Okay, so increase them by 1. So first everything is 1. So do you remember I said consider a table agreed with some tokens? So first, so something like this. So consider table like this. Yeah. So first color all these. So everything is 1. So for example, it says that this and this range, they should not be 1. So then move them up like this. And for sure clean. So move tokens to the next layer. Then read the triplets with m equal to 2 if the minimum of their, for example, this range, if this they represent like this range, so that's okay if the minimum is 1, or the else if they represent this range or something like this or like this, again move that to top, but move that one cell up like this, and so on. So read them one by one, and if minimum is currently equal to that m, increase them, increase the whole range by 1. So move the tokens to the next layer, and that's it. If you read some with m equal to n and you want to move it to the next layer, it isn't possible, and that's it. So let me see if we can implement it easily. Yeah, we can implement it easily. There is no tight time limit, so yeah. Oh, it was a easy problem, thanks God. So trips, triplet, for I in range n plus 1, while k, then LRM, right? LRM, then triplets of n minus 1. So I'm doing it, I'm making it 0 based. Dot append L minus 1 and R 0 based, and close open like this. L R close open, and finally start with 0 times n, and then for I in range n, for range in triplets, if minimum of RNG0 A from RNG0 to RNG1
is equal to I, set the whole range to I. It can't be done, right? Or it can do it. I don't know. Let's try. Finally, if n in A, okay, print -1 if n in A, else star A. Why? Ah, okay. If n in A, print -1, else print star. Okay. Okay, it can't work. I times range of 1 minus range of 0, 0, 0, 0. Okay. Oh. 0, 1, 1. Okay. Guys, what do you think about not making this 0 based? Okay. Let me check it out. Okay. 2 to 3, it should not be 1, but it wasn't. Okay, we got accepted. Great. And I don't know, maybe we can optimize this line, but I'm not sure. Let's solve the next problem. Did we solve right now this problem? I don't remember. Yes. Okay, let's solve this one. So I see a lot of constructive problems, and you know, I'm very bad in constructive problems. I'm good in data structures or yeah, those kind of things. Constructing problems, DP problems, they kill me always. But let's go on. We have 2 problems to go. I think we have 3 problems to go. They will add another problem very soon, but let's see. Jeff is still recovering from last round, so this time instead of biggest story directly give you okay. Given array integers non-empty subset that bitwise and is exactly equal to given integer k. Okay, that should be easy. That should be easy. So oh, that's easy. It's like this. So we go find, what's it say? Human period. Okay, that works. So that's easy. So if for each number, if it doesn't have a bit that k has, for sure we can't choose it, because if we choose it and we choose it in our subset,
it will miss that bit because they will end together at the end, right? So we miss that bit. So we only choose integers elements in our subset that they have all bits that the k has. So we choose a index like I where k and ai is equal to k. Okay, so actually k is a submask of ai, so we only choose these things, and at the end of the day we check if we add these things together we reach k or not, and that's it. So it's super easy. Okay, and k a is like this, and finally ans is like this, and current is like this, and if ai and k is equal to k, I pick this and start append I, and current ends with ai, and if current is equal to k, print star a, else print -1. It picked everything, right? Uh, Oops. Three, 1, 4, 5. Okay, that works. That works. That works. Three, 1, 4. I hope that it skips the. I hope that it skips the spaces that I printed. And so let's see. Okay, we got this. That's it. And the final problem. So I need to write some hints too. So let me open something to write hints. So for this problem, hint is don't pick numbers that if you pick them and will not become k for sure, pick everything else. Okay, that was a hint for this problem. Okay, it says that you are given two arrays A and B. You need to construct array C. A small index is defined as an index I that satisfies both of the two conditions. I is at least 3, and there exists index j and k such that J and K and I and Ci is less than or equal to Cj plus Ck. It wants to make triangle, right? So it wants to make triangle using J, K, and I. And it says that find the maximum number of small indices that you can get. So you want to find so are these arrays sorted? Given two arrays in construct. So it seems like they are sorted, but I don't know. Let me tell them that if it's not sorted, they need to. Okay. Okay. It's not that easy. Okay. Okay. Um, Again, a constructive problem, and I don't have any idea. maybe greedy. So process indices one by one. At each step, you have two choices. Sometimes you have one choice that's easy. Sometimes you have two choices. You have two choices that you put some small element and increase the number of small indices by one. Or you pick the big one and increase the level. So let me define level. Level means the sum of two largest elements of the array that we already filled. So when we are at index I, level is sum of two largest elements in the indices to the left. So either we can increase the level or increase the small indices by one. So we need to pick here carefully. It's not easy. Oh. Oh. This interesting fact here. Consider that in the tree is not a small. It means that it's at least two, right? The first ones. So I'm filling that I'm filling the array C. Okay. So consider the first element. So the first element is 1, second is 2, 1, and this one needs to be at least 3. Otherwise, it's for sure it's small in this. This one needs to at least be 5, because otherwise it will, yeah. Then 9, then 15, and so on. The thing is, it grows more than Fibonacci grows, and end of the day, there is so after a few terms, that's it. You can't find integer that's not a small index. So it's like this. So it passes. So sum of these two last elements pass 2 times n, and everything you put, it will become a small index. So small indices are super near to n actually. So it can be a fact, can be important in solving our problem. So um, we understand that there are very few numbers. In the worst case, if we fill C just at random, there are only very few number of indices that they are not a small index. So I wish n was smaller and we could do backtracking. This problem is not that easy, right? It doesn't seem to me It's like super easy problem. Okay, something is ruining my mind, so let me try something. Why? I want to calculate how many elements can be there. So A, I, and BI are at most 2 times 10 to the power of 5, which is something like this, right? Yeah. And tell me, how many numbers are here? 1, 2, 3. Very few. Very few. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 27. 27 numbers are here. So it's not that small as I expected. Twenty-seven is as big as if we do 2 to the power of 27, we will fail. Okay, folks, let me think more. So consider we already filled C to some index. Now we are at index I level, and we know the level and we know the maximum element before it. And we have two choices. If none of these choices can make a small index, so both of them, if both of them are above the level, for sure choose the maximum one. If both of them are less than level, again choose the maximum one, right? If one of them is more than level, one of them is less than level. If we choose the larger, we will extend the level.
So maybe we do backtrack and try our chance. What do you think? Maybe there are not that many states and it can pass, huh? What do you think? Let's try. I don't know if it's gonna pass or not, but let's try, and I will try with C++. That is sure much faster. Yeah, let's give it a try. Okay. Okay.
Either replace AI here. AI for sure doesn't. I don't care. Never mind. AI, and then we get this level and +1 because we for sure know that AI is less than or equal to level. Or we will solve in the second option, that is maximum of BI and then level and then so it says that it's infinite recursion. Okay, if I is n, return 0. Okay, looks good to me. Let's try. Three and 2. What? Why? That is because of I think that we fixed. No, it didn't fix. Okay, that's the problem. Okay, that's true. I'm almost sure that it will get time limit exceeded, but let's try it. What is this? Wow, we got accepted. I'm unsure that this is true. I will try the. I will do some investigation. I will notify the judge, I mean the problem setter, about this, and I'll make sure that this is really correct. And in the case that it was correct, thank you for watching me solving problems of ICPC India Prelims 2024, and maybe see you soon in ICPC Go for Gold camp. Bye bye.